Hello, this is Mr. Collier, and today we're doing related rates. So sometimes we use chain rule explicitly, and that might be a first step you see often in some of these answer keys. I kind of just do implicit differentiation every time, as I'll show you now in a second. So spherical balloon is expanding, so its radius is increasing at a constant 2 centimeters per second. So the radius is increasing, so that's dr dt, that's the rate at which the radius is increasing, is 2 centimeters per second. Okay, so that's dr dt. At what rate is the volume increasing when the radius is 8? So to do these kind of questions, we start off with an equation. In this case, the equation is going to be the equation for the volume of a sphere, which is 4/3 pi r cubed. And it's asking you for the rate of increase of the volume, so that's dv dt. Okay, we're differentiating with respect to time. So when I differentiate here, I'm going to be multiplying by 3, so I'm going to have 4 pi r squared, but I'm differentiating with respect to time, so I have to use chain rule and do dr dt. Okay, so this is the equation where I'm going to substitute in some of the values they give in the question, right? At 8 centimeters, so that's when r equals 8, and dr dt is 2. Okay, so I can just work that out. That is going to give you 512 pi cubic centimeters per second is the answer. Okay, next example, we've got an oil spill in a circular pattern whose radius increases at this rate. How fast is the area increasing? Well, we just use the formula for the area of a circle is pi r squared. So dA dt is 2 pi r times dr dt. So in these related rates problems, you just have to remember to use a chain rule. Basically, set up an equation, then use the chain rule. Then to figure out the area, you can substitute in, now to be the right units, yeah, they're both meters, so no problem there. And dr dt is 2, so that's 240 pi, and its area, so it's square meters per second. Okay, the next example, Bill, who is 1.5 meters tall, walks directly towards a street lamp, which is 6 meters tall. So let's say this is the lamp. And Bill we're on a flat ground, we'll assume. Bill is 1.85 meters tall. So the light from the lamp comes down here and makes a shadow. Okay, so we'll call y the shadow, and x is the distance from the lamp. The only things that are constant are the height of the lamp post and the person Bill. Find the rate at which the lamp of his shadow is increasing. So he's walking. He's walking away from the foot of the lamp. Okay, so we need an equation. We can make an equation because we have similar triangles here. So in this small triangle, we have 1.85 over y equals, okay, so this is 6 over x plus y. That's our equation. It's not so great now with all these fractions, so I'm going to cross multiply. We got 6y equals 1.85x plus 1.85y. What else is given in the question? It walks directly away from the street lamp with this velocity, so that's dx dt, right? Alright, and we want to find the rate at which the shadow is increasing. That's dy dt. So if I differentiate this implicitly, then I can get those values. Actually, let me subtract this from both sides first. This is going to be 4.15y equals 1.85x. and then I'll differentiate. 4.15 times dy dt equals 1.85 dx dt. Okay, but dx dt, we have that given in the question, is 2.5. So we're going to have 4.15 dy dt equals 1.85 times 2.5, so dy dt equals 1.85 times 2.5 over 4.15. Okay, if you type that into your calculator, you should get about 1.11 meters per second. Okay, in the next example, we have a 4-meter ladder is leaning against the wall and starts to slide away. By the time the base is 2 meters from the wall, the base is moving at 1 meter per second. Okay. At what speed, find at what speed the top of the ladder is sliding down the wall. Okay, let's draw a picture first. Let's draw it over here. Here's the wall. Okay, so you have the ladder sliding down the wall. So we have this situation, it's like a little right triangle. This is, we don't need theta yet, but let's put it in there. Okay, so a 4-meter tall ladder, so this is a constant 4 meters. We'll call this maybe x and y, I suppose, because these are changing, they're not constant. Next we need an equation with relating x and y, and one equation that comes to mind is just the Pythagorean theorem, right? Okay, so x squared plus y squared equals 4 squared, and then we can do implicit differentiation. We're differentiating with respect to time, always with the related rates. So we have 2x dx dt, 2y dy dt equals 0. And when the ladder is 2 meters from the base of the wall, that's the y value is 2, so we have 2 times 2. dy dt is 1. And here to find out the x value, we can use Pythagorean theorem. X is square root of 16 minus y squared, which is going to be root 12. So this is 2 times root 12 times dx dt. So solve for dx dt, we have, it's going to be negative 4 over 2 root 12, which equals negative 4 over 4 root 3, right? So it is just negative 1 over root 3, or negative root 3 over 3. Makes sense as negative because the x value is decreasing because the ladder is sliding down, right? So that's meters per second. Okay, so next we're going to look at the area, the rate of change of the area. So area equals a triangle, so it's going to be half x times y. So when we find the derivative with respect to time, we're going to use product rule. We're going to half the derivative of x plus half x times derivative of y. And we have all these values already. We have dx dt was negative root 3 over 3, and then y is 2. Then we got half times the x value is root 12, which is 2 root 3. And then dy dt is 1. So we'll have negative root 3 over 3 plus root 3, which equals negative root 3 over 3 plus 3 root 3 over 3, which is 2 root 3 over 3. And this is area, so is it centimeters? It's probably meters, right? Meters per second. Okay, so next we're going to do the rate of change at which the angle is changing, and that angle is getting smaller as the ladder slides out, so we should get a negative answer, I suppose. If we look at the picture, we could do cosine is y over 4, and Or we could do sine is x over 4. I think I'll stick with cosine because we know dy dt is 1 and the y value is 2, so we can avoid lots of surds if we do that. So we have cosine theta equals y over 4 is our equation. Cosine theta equals y over 4. So when we find the derivative with respect to time, we get negative sine theta d theta dt equals a quarter times dy dt is our derivative. And so we have dy dt is 1. Now we need to find the angle. I guess we can figure that out because we have this is 4 and this is 2. So what's that angle there? This is 2 root 3. This is a special triangle. So the sine of theta is going to be 2 root 3 over 4. And d theta dt equals a quarter times 1. So that means that negative 2 root 3 d theta dt equals 1. If I multiply both sides by 4. So d theta dt equals negative 1 over 2 root 3, which equals negative root 3 over 6. Okay, and that's radians per second.